Okay, so to frame this talk, this is all about UI implementation, but some of you don't do that, and I think this is still actually applicable elsewhere, so listen for the underlying principles. And finally, despite the fact that the title says your constants, and I say you a lot on purpose in this talk, I'm using that to provoke thought, but not to provoke despair. I'm not trying to shame you or call anybody out or anything. I've done all this stuff too, so with that, if you got a CS degree, you probably have this drilled into your head. No magic numbers. Don't do that. Don't use them anywhere. And then you got to Google and heard, welcome to Chrome. Please go implement this mock. Your milestone branches in 10 days. And there were magic numbers all over it. So what you probably did, given the fact that this is pervasive in Chrome, is you wrote a big block of file scope constants atop your file and put all the numbers from the mock in there. What's wrong with this? Well, potentially nothing. But usually if I dig into this, I find at least one of the following problems. So hence code smell. First problem, your designer's mock looks good in isolation, but did UX have a product-wide unified visual language? Did they apply it here? Did they miss anything? Did you translate it faithfully? If you have a hard-coded constant, it's really easy to build inconsistent UI, and it's really hard for a tool to catch when you do it by accident. And inconsistent UIs don't just look unpolished, they're actually harder to use. And if you want to know more, go talk to UXR, because I'm sure they would regale you. Problem 2, Chrome has hundreds of surfaces. I'm not exaggerating. It is literally hundreds. There's no complete list of all of them, even though we've tried several times. So when the next redesign happens, are we going to find your magic constants? And then are we going to know what numbers to change them to? File scope constants make your UI brittle, so redesigns are likely to cause bugs even if you're consistent today. Problem 3, numbers tell you what something looks like. They don't give me much context though. So if the definitions just restate the things on the mock, I can't answer any of the questions that I'm asking on this dialogue, and that means I can't spot subtle bugs with your implementations, either during review or later. I need to know not just what the values are, I need to know why the values are. I need to understand the function and not just the form. Problem 4, the opposite problem. At usage sites, the names don't tell me what the effects of the constants are. This code doesn't mean anything to me in terms of what does it actually look like. So to know that, I have to go look outside the current code and bring in things mentally from other scopes. Problem 5, we have lots of common controls with default behaviors and appearances. And then a lot of our code uses constants to customize them back to the defaults. So were you just writing them out for local clarity? Did you specifically want those values even if we change the defaults later, and why? Did you not know there were defaults? I don't know, but the more constants that some code uses, the more opportunity there is for me to worry. Problem 6. People hear no magic numbers, and so they assume, oh, snippet A is terrible. Look at that 158 right in the middle of nothing. Snippet B is much better because now we've given it a name. Well, which snippet's easier to read? I can read A faster. Which snippet gives you more information? A actually tells me more despite saying less, because what it tells me is this value is never used below this unless you explicitly went and restated the number. With B, who knows where that variable goes out of scope? Which is easier to maintain? If I change the argument type for set max size, A needs 1 edit. It appears in cross references. B needs 4 edits. 2 of them are in variable names. That's very hard for a tool to automate. So actually, both these snippets still have a magic number. Naming it didn't get rid of it, but it did make it more awkward to use. Problem 7, this code compiles fine, which is a problem because your constant is not used. What does that omission mean? Did you forget to pass it? Is the code buggy? Was the constant vestigial? Is it used by some other object file and just defined here? I don't know. Problem 8, less important. Until 2017, Chrome had a build config called Jumbo. It reduced compile times by compiling groups of source files as concatenated things. If you do this, your file scope symbol is not a file scope symbol anymore. It's a concatenated group of files symbol. And that means all of these 91 files are symbol conflicts. Now, we removed Jumbo 7 years ago, so this hasn't mattered. But a 2024 ATL OKR is to reduce build time. And to support that, I'm experimenting locally to see whether reviving Jumbo might be worth pursuing. Guess what's really annoying to fix? So Finally, like all these things might make this a code smell, but they're not always wrong. Sometimes they are the right trade-off. But is that why you use them, or is your code just copying other code? If a reviewer asks you to change something, do you investigate and discuss until you understand the trade-offs, or do you just immediately comply so you can land before the branch point? File scope constants make me wonder about the rest of the code. And ultimately, I'm not telling you not to use file scope constants. I'm telling you, think of the big picture. Your job isn't to build features, it's to improve and maintain cohesive products. So understand how your code fits with the whole, understand the underlying function and why it should cause this form. Don't assume your mocks or your specs or the code or review comments or this lightning talk is correct. Keep asking questions and probing until you understand, and then go build something that to the greatest degree possible is not only going to work well now, but keep working in years to come. End of talk.
Perfect. Any questions for Peter? Would it be fair to say that this is file scope constants that have a single use in the file? Or do you have opinions on ones that are used multiple times?
So some of the previous problems apply to both and some only apply to one. Things like the two snippets, one is easier because you inlined it, that's only going to be possible with a single use case. But even if there are multiple uses, things like consistency across the product still apply. And in fact, I've also a lot of times found that multiple uses is because people factored out repeated logic into multiple different helper functions that then all have to do the same thing. And if you go back, re-inline everything into a massive function, pull the constants in, and then back factor it out, in a way to repeat code as minimally as possible, it becomes a lot shorter.
Other questions for Peter?
Do you think, oh, sorry. Do you think if we move to a system where we don't use magic numbers and you like percentiles, more layout specific things that can resize, is that ideal, or is that just asking for trouble?
I mean, the devil's in the details on a lot of these things. As an example, take GM3 tokens. A lot of colors are defined via tokens now, but sometimes those tokens obscure meaning rather than adding meaning, like the style body 3 thing I had earlier, like that didn't actually help because that's still very tied to like a low level physical presentation detail. So would it fix things? Maybe, or it might make them worse. It really depends on whether we're expressing true semantic shared meaning or not this way.